Questions on 211?
18.
18.
I did that one actually. I thought I did it right. I hope
Let's see, a surgical technique is performed on 7 patients. You are told that there's a 70% chance of success. Find the probability that the surgeon is successful for exactly 5 patients, at least 5 patients. I'm hoping you guys got your calculators because I don't have my calculator right here.
Uh-oh.
And less than 5 patients.
I don't have to think. Broke it.
So we need our N, P, and Q. What was N?
And it's 7.
P,
7.70.
and then 0.3 for Q then. And
I
let's
got
see.
that part right.
0, 1, 2, 3, 4, 5, 6.
Part, so, and the X is
0, 1, 2, 3.
all the way up through 7, right? But we only want to deal with which ones, I think, isn't it?
At least 5, less than 5, and exactly 5.
So we want 5, then we want, on the second part, we want
At least.
at least 5. So that would be 5, 6, and 7, right?
And then less than 5.
So that'd be like 1, 2, 3, and oops, I forgot 0, 4. So to do this, what?
I use the packet.
Use this.
Yeah.
I think it's kind of easier.
Is it
Yeah,
easier
if-
than
if-
using the calculator?
Because you can't
I
do
think
it if
so.
the like P is like an odd or not a multiple of 5, right?
Now, this one works out using this because it's 70%, right?
But if it was like 29. you
Right,
can't.
but if it's 29, you can't.
But yeah, I use the packet for this one.
So I'll show you without using the packet how to use the calculator and to make this easier. If you read the whole problem, this is part A, this is part B, this is part C. If you read the whole problem and know what you got going on in the problem, then you might be able to make it a little easier on yourselves. So for part A, we want the probability that there's exactly 5. So on our calculator, what do we punch in? We go second,
There's
the bars thing there,
And then,
P, or no, not.
Go down
the one that
to
isn't
PDF.
CDF.
binomial PDF, or go to PDF for this one, because
Oh.
we're just doing one. Binomial PDF,
and then type in your N.
and you put in 7. What do we put in next? Is it P?
7,
And then,
5.
I can't never remember which order they go in. So it's the N, the P, and then the X, right? And what's that give us for that one?
0.317.
Anybody else get that?
The packet said 0.318.
Oh yeah, you could
If
probably.
you round up.
Same difference.
So, if you're within that one there, because sometimes it'll be a little different if you add different stuff, but if you're within that, this is tenths, hundreds, thousands, if you're within that 1,000, one way or the other, probably all right.
Count it right.
Now, what I was going to say, instead of doing B next, if we read the whole problem, if we do C next, because C is everything from 4 down.
You can just subtract.
So we can go we want less than 5. Well, on your calculator, you can use, instead of using binomial PDF, you can use binomial CDF and put in 7.7 and 4. Because we don't want to include 5. So we put in 4.
0.353.
Yeah.
Now, if we look at what we were finding for C, we were finding probability of 0, 1, 2, 3, or 4. For B, we were finding we want to find the probability of 5, 6, or 7.
We already have the 5.
Well, if you put all these together, that's the whole thing.
Should be 1 minus.
So we can just take 1 minus that 0.353. What's that give us?
0.647.
Now, we could have on B, we could have went through and found the probability of 5, which we already have, and then just said, went back and found the probability of 6, and the probability of 7,
Let's just subtract.
and just add all them up, then took that answer and subtracted from 1 to get this answer. So I don't know which way is easier, but if you want to use the calculator more.
Can we do 19 then, just the few more?
19. Sorry, I was just looking at the answer at 18, make sure that we were right. 19, 59% of men consider themselves fans of professional baseball. You randomly select 10 men and ask each if they consider himself a fan, if he considers himself a fan of professional baseball. Find the probability of the number who consider themselves baseball fans is exactly 8, at least 8, less than 8. So for part A, it's exactly 8, so we want probability of 8. Part B, probability at least 8, that means 8, 9, or 10, right? This is not the proper way to write this. All right, so don't go off to college and write your crap this way and think that your professor is going to be happy with you.
You got the right answer.
And then probability of less than 8, I'm just going to do this. So probability of 8, we can just punch that into our calculator using the PDF. So we're going to put in binom, PDF, and we put in, I guess we need our N, P, and Q, don't we? I didn't write them down.
10.
So 59%,
Yeah.
so 0.59, and then that's a 9, and then Q is 0.41. So it's 10, 0.59, and 8.
0.111.
So about 11%, there's about 11% chance that if you pick 10 people at random, that 8 of them are going to say that they are fans of baseball. All right, and that's another thing you got to remember, because the stuff we get into today is going to be something a little different. So what we're saying here, we're saying we know what the big picture is. If we go out on the street then and we pick 10 random males, what's the chance that 8 of them are going to say that? And it should be about 11%. So if we go to our school and we know our school has 400 students and 200 of them are males, we should be able to figure out how many of them are fans of baseball or basketball or football according to this. Same idea on this one. Instead of doing B next, might be easier to do C next and use, instead of binomial PDF, use binom CDF. And we put in 10, 0.59, and we want everything less than 8, so we want to start with 7. What's that give us? So about 85% chance that if we go out and ask 10 people, there's about 85% chance that 7, 6, 5, 4, 3, 2, 1, 0 are going to say that they like baseball.
That means that B is 1.52.
And to find B, then we can just take 1 minus that. And what was it?
0.152.
0.15.
And again, we could have found the probability of 8, which we already had right here. And being on your calculator, you can hit that, hit second and enter and just go back up to it. You just change the 8 to a 9. And then do it again, change the 9 into a 10. And add those 3 up. And it should give you that same answer. And we could do the same thing on this one. We could have punched it in our calculator once, punched in 7, 6, 5, 4, 3, 2, 1, 0, and then just add them all up. I think on the test next week, this one has 10. I think the biggest one that I put on the test that I make you do a probability distribution for, I think the biggest one, and we have to draw the chart for it, I think it goes up to like 27. So you have to go 0, 1, all the way up to 27. See, I just wanted to see if Riley was still with me or not. She was off in space somewhere for a while. She heard that though, didn't she?
I did.
Next question. 28. No trouble sleeping. 1 in 4 adults claims to have no trouble sleeping at night. You randomly select 5 adults and ask them if they have trouble sleeping at night. We want to make this one. We want to make the chart and everything for. What's our N first of all in this one?
5.
How many adults did we pick?
5.
5. What's our probability? It says 1 out of 4, so what's that mean? 0.25. I'd change it. I wouldn't leave it 1/4. That's a pain in the butt. 0.75 for Q. I don't know if we really need that. Our X's. What's our X's going to be?
0, 1, 2, 3, 4, 5.
We'll make our chart. I'm not sure why I made that so big. It doesn't need to be that big. Our X's, 1, 2,
0.
oops, sorry, 0, 1, 2, 3, 4, 5. Then we just got to find the probability for each. Easiest way, can we use the chart on this one? So if we use the chart, because they're all listed right there for us, if you can't use the chart, then just in your calculator, you're going to punch in binomial.
Could you do CDF and then do 5?
No, because it would tell you all of them together. You want each one separately. So you have to do binomial PDF, and you just punch in 5, 0.25, and then 0, and then just keep going back and changing that number to get all the rest. So if we use the chart, now I'm not going to be able to read the chart, so you guys are going to have to help me if we're going to use the chart.
I can't read the chart, to be honest with you.
You go to 5,
Go to 5,
and then go to 0, and then go to 0.25.
and we want 0 first and over to 0.25,
237.
237. Then you should just be able to go right down that column.
0.396, 0.264, 0.088, 0.015, and 0.001.
001.
Yes.
28.
That's crazy. I can't even say that. It's so small.
Or start, get a piece of pair of glasses.
Yeah.
Magnifying glass.
Mine goes comes in.
What'd you guys say?
So if we have that, then they wanted a
Graph.
histogram or
Get rid of
graph.
those glasses.
Okay, yeah, now I get it. I get the concept
And all we're gonna do on our histogram over here is gonna be our probability. Usually it's frequency over on this side, but now it's probability. On this side, it's gonna be number, no trouble sleeping, or whatever it is, no trouble sleeping. And for our bottom, for our horizontal, we got 0, 1, 2, 3, 4, and 5. And then we look at our numbers here, it goes up to about 40%, all the way down to like 1%. So we'll start it, just go by fives. I'm gonna do it this way, 0.1, 0.2, 0.3. Everybody understand what I just put there?
Yep.
Do I need the zeros on the ends?
No.
Would that make it easier for you to understand? 40%, 30%, 20%, 10%. First one's about 23, 24%. So I'm just gonna draw something that's gonna go about there maybe. Second one's almost 40%. About like that. 26%. So just a little higher. About 9%, so a little less than 10. 1.5%, so I'll probably take off points if you make this one way too small or too big, right? I'm not gonna be able to tell. And then the last one, not even 1%, so you might just do something like something real small right there. Then they also ask us several other questions. I don't remember what they were though. Graph it. Find the mean, variance, and standard deviation. How do we find the mean? N times P. So 5 times 0.25. That goes.
1.25.
So that's our mean. Now you can look, remember your mean should be what's sort of right in the middle, halfway. If we look at 1.25, that'd be somewhere like in here. Does it look like about half of the stuff is on this side and half the stuff's on that side? Yeah, it's not too bad probably. Then all we do to go from the mean to the variance is we take that number and we multiply it by the cube. What's that give you? Then you take the square root of that. What's that give us? Say it again. Now, some other things that they ask us, and this you got to listen to closely because we haven't dealt a whole lot with it. We talked about it some in other chapters, but we're going to start doing it more and more and more. You got to be able to explain this. And what this says, we know that our mean is about 125, so about 1 1/4. So if we pick 5 people, we're saying that we should average getting about 1 1/4 people who say that they have trouble sleeping. This tells us that this is real close to 1. And when you're talking about people, you sort of got to round stuff because we can't have 0.968 of a person. All right? So you got to sort of round stuff around. Even the 1/4 here really doesn't work. With our standard deviation, we're saying that going down or going up, one way or the other, we would be about 1/4 of a person up to 2 1/4 people. So we're figuring, if we go out and we do this, if this is our job to pick 5 people and ask them about their sleeping, if they have trouble sleeping, we're gonna normally get somewhere right around between 1 and 2 people. Otherwise, we're gonna fall somewhere probably between 0 and 3 people most all of the time. That's what the standard deviation tells us, that we're gonna fall in that range most of the time. So if you go out and you're getting, or let's say Lily's the boss, and Isaac's going out and he's coming back and he's getting 5 people all the time, Lily might know that, hey, Isaac's probably not asking anybody. He's going home, going to bed, coming back, turning in his crap and getting paid for it.
He went to the market.
Yeah. So that's probably not gonna happen a whole lot. The last thing they asked you was, are any of these probabilities unlikely? What's unlikely to get? Remember, unlikely means, or unusual means it's gotta be less than what? Less than 5%.
Yes.
Any of them less than 5%?
Yes.
Which ones?
5.
4 and 5. So if Isaac's coming back all the time with 5s,
Something's up.
something's up. He's probably not, again, he's probably not doing his job. He's probably just going out there and he didn't know. He just got this job and he's thinking, who knows? I'll just throw some stuff down here and I'll go sit somewhere in the barn, sit and get drunk and then
The barn?
bring my stuff in.
Barn. Oh, I thought you said the barn. Gonna go sit in the barn and get drunk.
Oh my gosh.
Does Lily have a barn at her house?
I don't.
All right, because I was wondering where that thought process came from.
That's what I've heard. Don't
Somebody
have a
close to her
barn.
probably has a barn, don't they?
Everybody has a barn.
I don't.
I do this.
I can tell by Riley's, the look on Riley's face, she's going, oh my God, Ebersole knows about Lily now.
Don't know your secret.
Oh no.
Other questions?
What are you gonna do?
Think you can handle that?
Yep.
See some today.
I
didn't show
Hi, my name's Julie, and
Do
I'm
what?
sitting last one.
Again, the stuff that we're gonna do today, that was binomial, so we were saying,
Oh, it goes.
if you know how many things you're doing, what's the probability of getting this many out of that? Stuff we're gonna do today, there's 2 different setups. And one of them is, if I start doing this, whatever it is, this procedure, when am I going to get the first success? So, like, what's the probability that the first success comes on my first attempt? What's the probability that my first success comes on my 10th attempt? All right? And then the other one is, if I have this space right here, let's say I have this area on this desk, what's the probability that it's black, and what's the probability that it's white? And we're going to be able to figure out whether, how many, if I just pick this little bit right here, how many black spaces, what's the probability of getting a black space, what's the probability of it being a white space? I pick this space, so on and so on. So we're picking it out of something. All right? That might not be the best way to, something like that one, maybe, let's see what's a better way to explain it. You'll understand it when we get to it. Just out of a certain area or out of a certain maybe, let's say you're going down to the creek and you're getting water out of your creek and you want to see what's the probability that you have larvae in it, mosquito larvae, and they carry germs and everything else. We can do stuff like that with it. With this, your title you might want to put on this, other Distributions. Other distributions. Sorry, that's sort of crappy. And I just put this first slide on here just to go back over this. If your probability is greater than 0.5, so greater than 50%, then remember it's skewed left. Skewed left graph, and I'm not going to draw the bars every time. A skewed left graph means that the tail's on the left, so the graph would probably look, it'd have the taller stuff down here, and then sort of fade off that way. If the probability is less than 5, less than 50, or less than 0.5, less than 50%, then it's going to be skewed right, so it's going to be tailed off this way. And if it's symmetric, then it's going to look more like the bell curve. And if it's the other one that nobody can ever remember,
Oh, I already forget it. Uniform. Right? Yep.
we don't have that one, so, because they don't come out that way. Geometric distribution, and we're going to cover two distributions. Oops, sorry. Thought there was something else on that one. Represents a situation where a trial is repeated until a success occurs. So geometric, we're doing this same thing over and over and over again until we get a success. What I do when they make me do those online, all the online stuff that I have to do like 3 times a year. I go in, I take the test before I watch the videos and everything, and I just keep taking the test until I pass it. I shouldn't have recorded that. Too close to retirement, they can't fire me now. It's too late.
We go back.
Or forward.
Oh, yeah, forward.
Switched on that end.
Next. You see, it's too late.
So when we do the test next week, you'll have to know, hey, what am I dealing with? Am I, what's this problem saying? Am I just looking at like we were doing and saying, if I go out and pick 10 men, what's the probability that 8 of them are going to say this? Or am I doing something like this where if I go out and I pick these 10 men, what's the probability that the first one says it? Or the probability this is just saying what's the probability of which one is going to say yes first?
Crap, we have a game.
It's what Michael does when he's trying to get a date. Just rapid fire out at the grocery store. Hey babe, you want to go out?
No.
Hey babe, you want to go out? And just first success.
Eventually one of them says yes.
Exactly.
I don't care how old you are.
So geometric distributions, a discrete probability. Everything that we've done in this chapter has been discrete probabilities, and it satisfies the given things here. And the formulas down here at the bottom, that's very key. Again, don't write all this stuff down word for word. To be a geometric distribution, trial is repeated until there's a success. The repeated trials are independent of each other. So when Michael's asking each girl, he doesn't ask this girl and then ask her twin sister that's standing right next to her, because that might screw up the fact that they're independent of each other. Or her, what's it called when, her Siamese sister that's right next to her? Is that what it?
Tour, like one head's here, one head's here.
Ew.
They could be very different, Michael, you never know.
The probability of success, P is constant for each trial, so it's the same for each one. Random variable X represents the trial when you get to first success. And then that formula, this formula is not real difficult. It's not a real hard formula. It looks confusing sort of, but there's only 3 things, and we just plug into those 3 things and do the math. Plug it all right into your calculator.
Wait, what's the name when you said the probability of success P is constant? So when it's successful,
Probability, that means it doesn't change. So the probability of, if I'm, let's say I'm shooting, and I'm gonna shoot it to trash can until I make it, the probability when I shoot the first time, that probability of me making it or missing it stays the same as if I shoot it the second, the third, the fourth. So in other words, I don't shoot it the first time and break my arm, and then now all of a sudden it's going to be a little harder for me to make it, and it changes what happened.
Isaac, did you go to school when you were
It's actually pretty cool.
Yeah, the letters.
The elevator was kind of going right line. I'm actually no short.
It's actually pretty warm outside. I think that's kind of nice.
Get on this formula, all you're going to do, find the probability, whatever, and they're probably going to tell you that. Find Q. That's just P times Q, and Q is raised to the x minus 1 power, where x is what you're looking at. If you want success on the 5th try or the 7th try, that's what x is. So we don't even have an n on this one. From experience, you know that the probability that you will make a sale on any given telephone call is 0.23. Find the probability that your first sale on any given day will occur on your 4th or 5th sales call. So let's say you work for some company, and you want to, as soon as you make your first sale, you get a quit calling people for the day. All right? And you want to figure out, hey, what's the chances that first person I call today, I get to go back to bed afterwards? This is what they're talking about here. So on this, we just got to find P, Q, and X. What's P this time? 0.23. What's Q?
7.
What is it? Yeah, you guys are right.
Yes, that's
Oh, I was just, you made me feel
just
stupid.
because Ebersole put 67 doesn't mean it's right.
0.77. And then our X, what's our X this time?
4 or 5.
4 or 5. So X is 4, X is 5. We've got to do 2 different ones. All we're going to do, find both of them and add them together. So probability of 4, probability of 5, add them together. That's going to give us a probability that our first success falls on one of those. The formula was P times Q to the x minus 1. So for 4, P is 0.23 times Q, which is 0.77. And we're going to raise that 0.77 to the 4 minus 1. What is 4 minus 1? And for the second one, it's going to be, everything's going to be exactly the same. So you could punch all this into your calculator
Then you raise this to 4.
and then just change that number on the exponent the next time.
Wait, so you add, can you add these while
Yeah,
typing
we-
into the calculator?
Yeah, I guess you probably could. You could probably type all of that right there into the calculator all as one thing.
But it says, does it want one answer or does it want two?
It wants the fourth or fifth call. So it wants both of them together. What is it?
0.18 or 0.19.
0.19?
Yeah, I wrote that.
If that's right. .186, pretty close.
What's the background?
It's like old Renaissance time or something.
Just kinda like look at it
What
like.
are the things say?
Rith,
PBS.
A something, something, backwards E and a W or an upside down L.
Taga, Ross, Botivus.
PY.
I don't know, you'll have to look all those words up, they're probably
EB.
Greek or something.
Yeah?
Yeah, on there, John.
You're on time.
I wanna know what Botiva is.
On this one says, Riley makes a free throw shot about 47% of the time. Find the probability that the first free throw she makes occurs on her third or fourth attempt.
Fictitious person.
So what's our,
It's a big word for
what's our probability this time?
47.
0.47, what's our Q then?
53.
And our X's are 3 and 4. So I'm just gonna write it out this way this time and we'll add the two together. 0.47 times 0.53. The power, the exponent that we want this time for 3 is 3 minus 1, or just 2. 0.47 times 0.53. And then 4 minus 1, which is, 4 minus 1, which is 3.
2.
Did you add them together already?
Yeah.
Try Mary.
So about a 22% chance that she misses the first one, misses the second one, and either makes the third or the fourth one.
She doesn't shoot a free throws a game to shoot that.
Wait, you got 22 too? I got 2 0. I thought, it's just a so it's the lead.
Oh no, I don't have my calculator, so
You can borrow mine if you want.
punch it in.
Okay.
You don't check it?
No, I just want you guys to punch it in. Fine. If I wanted to check it, I could go back and get my calculator.
I reread it, I typed it in there.
Wait a minute.
I got 2
Raised.
0.
Just do it.
Add.
Did we really help the team out last night?
Not gonna lie, it's 0.
Is it?
That's what I got.
Oh, yeah.
So about 20% of the time, just punch something in wrong.
Yeah.
You look at the ball like this. Go. You don't keep the hand.
I didn't realize I had all this up here.
What?
Yeah.
Tell me when you pass, you like.
I don't usually get the ball.
True.
I know I get the ball the first time I come Miami.
That's what I'm saying. Like when you go from Miami. You're like,
Next one says, find the probability that she makes her first free throw before her third attempt. So that means, what's the probability that she makes it on the first attempt or the second attempt?
So do we have to do both formations?
Huh?
We have to do both variables.
So you could do 1 and 2 now. What I'm gonna show you here in a few minutes on your calculator. So if you grab your calculator right now,
I got it. How you get that?
it's got a Geomet PDF and it's got a Geomet
I got it.
CDF, same places as the other stuff was. If we want the probability, like on this one, that she does it on 1 or 2, well, that's the very beginning of it, right? So we're just going 1 or 2. That's going to be the CDF. We can just put 2 in there and go down with the CDF. Or we could do PDF with 1, PDF with 2. Now when you plug it in, because this time we don't have it in, I got to remember what you have to put in. I think maybe you just have to put in the X and the probability. So if we do 2, if we just put in 2, because we want 2 and below, and then the probability was 0.47, does that give you anything, or does it say error?
Error.
So that must not be right.
Oh, I didn't put it in right to be honest.
Still says there.
I don't know, we'll find out here in a minute. I can't remember what all it wants on that one. It's on my PowerPoint here, but I don't remember. So if we do PDF, try Geomet PDF and 2 and 0.47. Does that still say error? Nobody wants to do it?
Yeah.
Yeah.
Still says error?
That's annoying there.
Oh, well, I'm still a long way. 0.47 times 0.53. If we're doing 1 minus 1 is just 0. 0.47 times 0.53. And if we're doing 2 minus 1 is 1.
Then you add them.
Then you add them together.
Like 1.7.
Point what?
1.7. Nice.
Ignore that.
Look, X. Look at the little head.
There's the stuff for the
Go
calculator.
down to D.
Let me see, put in P, comma, X. Oh, wait, I was putting them in backwards, I think. Did I tell you to put in X first?
Yeah.
No. I was putting them in backwards. The new calculator stuff, again, you guys don't have to worry about that because nobody's got that calculator. Hopefully, Texas Instrument quits selling them. Stupid things.
The ones with like the LED screen?
Yeah, it had all this crazy stuff on it and everything.
You can still buy them, they're just outrageous.
Stupid to have.
Mine's from here.
Mine's from this.
Marissa?
Mine's from this store I saw.
Mine's from Walmart.
Hello.
So again,
Forever though, I'm
you might want to write up here, this is the geometric stuff, so that you don't get them confused. You had the geometric, you had the binomial. The CDF, the CDF on the geometric again, CDF does the same thing. It starts at whatever number you put in there and goes down. So the CDF adds them all up going down. So if you need something going up, you'd have to find it going down, then subtract from 1. LeBron James makes a free throw shot 74% of the time. Find the probability that the first free throw he makes is on his 3rd or 4th attempt. We did this already, same thing as the last ones we did, so I'm going to skip over that because I really don't care about LeBron James. The next distribution. So we got the geometric distribution, then we got the Poisson's distribution. Poisson is some guy's name. I don't know who he is. I'm sure he's some kind of mathematician from a long time ago.
That guy's name.
So with this distribution, what it is you're looking at how many times a specific number occurs in a given interval or a given amount of space or amount of time or whatever it happens to be. There's many, many different things it could be. So we could look at something like how many cows are there per acre in Preble County, right? And we're probably not going to go all around Preble County and count up every cow and then figure that out. But what we can do is we can look at just little samples all around and get a general idea. And that's what this does. And for every sample that we do, everything should be the same. So we're not going to take a sample where,
There isn't a California.
well, where it's not sensible, let's say. I can't think of anything with that, with my setup here, with my example, that wouldn't be sensible. Huh?
On an elk farm.
With the middle nucleus.
Well, but we want to count those acres though, still. So even if it's,
You didn't know there
Don't
was
say
an elk
there.
farm?
don't say stuff like that, because now you got Michael.
What?
You gotta be with
He's
wondering.
distracted.
There's an elk farm like not.
I don't say such.
It's 2 houses away from me.
Sorry.
He's distracted now. He won't be able. Number one, I know what's going through his mind. What's an elk again? He's trying to picture what an elk is.
No, I got no.
No, come on now.
I got it. No, I got it.
Yeah.
What's the second reason?
What's the second thing going through his mind?
Yeah, what's the second thing going through my mind?
Nothing else.
What sound does it make? That's the second one.
It sounds like an elephant. Sometimes.
Within a given interval. So you're looking at stuff like that and trying to figure out. A lot of times this is done with water. How many If you have to have somebody come out and test your water that you have in your house, they'll get a cup of water out and they'll test it and say it's got this many parts iron per something. Now, did they test your whole well? No. All right, but they took this little sample, and that's sort of what Poisson's distribution is.
Y'all ever heard of Tablet? Yeah. I don't.
You don't have nobody test your water.
No.
So Poisson's distribution, again, it's a discrete distribution, and it satisfies these things. At some point, somebody had to test your water, or they wouldn't let it.
Probably, but not since I live there.
Or not that you know of.
They do it when I'm not there or something?
I mean, like, if you have a well, maybe they just go out there and just, you know, play. I don't know how you test water.
Maybe they just go out
We
to
just
my
dig our
house.
well up if we usually.
Why?
Get some hose water. I was gonna say outside.
Ours is like a bunch of trenches.
So it's got to satisfy this. The experiment consists of counting the number of times an event occurs. So how many times does this event occur in a given interval? So we might say something like, in the next 20 free throws, how many will this person make? And that's our X. Our random variable is how many will be made. Or how many cows are there in each acre? That would be our X. The probability of an event occurring is the same each time, so that probability, again, just like on all the rest of them, it doesn't change. So you can't, I was trying to, again, think of something that I could use with the cows, but I really can't think of anything.
Cows?
You can't have something where it changes the probability, all right? If there's, let's say there was a desert somewhere in the middle of Preble County, and we know that nothing could live there. It was so hot and ridiculous that nothing could live there. Well, we couldn't use that as part of our study because that changes the probability because cows couldn't live there.
But the cows can't move on the up problem either. Screw that.
The number of occurrences, notice how I just ignored you, right? The number of occurrences in one interval is independent of the number of occurrences in another interval. So in other words, if we go out and we pick the acre right next to the school, then we pick another acre somewhere over around New Paris, another acre over around West Manchester, they're all independent of each other. They don't affect each other. Poisson's distribution has this formula. Whole lot nicer of a formula here.
Looks like it.
Jenna, it ain't that bad. Quit
I can't read.
letting your eyes pop out of your head.
No, I need better glasses, is what I need.
I mean,
We can tell you can read the chart.
the chart is impossible to read.
No,
Sorry.
it's not.
Yes, it is. If you can read that chart, where you like 25, 20.
I literally have reading glasses.
Sure as long as we use the restroom.
No,
You gotta be blind.
And I didn't even fill out pads. Michael did.
I know.
Now with Poisson's formula, this formula is not all that real difficult, but instead of using it, we're probably going to use the calculator most of the time on this formula.
Mr. Can I go after him? I was supposed to go, but he took off on me. Thank you.
With Poisson's formula here, this is mu. What's mu again?
Mean
Mean of
Probably that.
population.
population. X is how many we're looking to get. That's mu up there, but it's got to be the negative mu. This is just X. What's this little symbol? Factorial. So if it was 5, it'd mean 5 times 4 times 3 times 2 times 1.
I hated that.
This is E.
That bad.
I
You got a
sucked.
button on the calculator.
On your calculators, E is just, it's a number like pi. Did you guys have E in one of your science classes or pre-calc or something?
Yes.
Right, so E is just like pi, it's an actual number, and this is sort of what it is, 2.71818, something. It's like a number like pi. It's programmed into your calculator.
Whoever added letters to math is just
Oh, I wasn't finished.
Oh, I'm sorry.
That's all right.
There
You
you got it?
Yeah, I'll just finish it. Ugh, I only have like 3 minutes. Sticking out like a
I'm going to skip over this example because I want to show you and we may come back to it, but I just want to show you the way to do it using your calculator. This is how you use the calculator. Again, don't worry about the new calculator stuff. Just write down the stuff for the calculators that we have.
I left my, water bottle in my car. It's freezing, and I put ice in it, so
I brought hot coffee this day, and I went in my car, and it was so cold in my car, and I opened it up, and it's like steaming so bad. I was like, and I never
She said, it cooled down.
I thought it did.
She didn't.
So when we do take this test next week, you're going to have to be able to pick out whether it's a binomial distribution or if it's just a regular distribution. And then you're going to have to be able to read the question also and know, hey, am I using binomial distribution? Am I using geometric distribution? Am I using Poisson's distribution? And the way you can know that, those three, binomial distribution, we're just saying, like we were doing the other things, I'm going out, I'm picking out 10 people. What's the probability that 8 say yes? A geometric distribution is, I'm going out and I'm picking 10 people. What's the probability that the very first person I pick says yes? When's that first success come? And Poisson's distribution is, I'm going out, I'm picking 10 people. What's the probability that exactly 7 of them say yes in each of these areas?
areas is,
Amazing. Thank you.
I did, but like, hey, when I eat.
So on this again, second bars, same setup. Go down, I think it's B. Is B right? Is that where Poisson's is?
L to B.
And you might want to make sure that you put, this is for Poisson's distribution.
Yeah, it is. B, you have to go all the way down past 0. I thought he meant like 2, but.
Wait, what?
You have to go all
It
the way
goes
down.
all the way to 9,
And then
1 to 0,
zeros.
and then ABC. It's B.
Oh, if you keep scrolling down.
So you just keep scrolling down. So you gotta be able to find Poisson's on there, you gotta be able to find the geomet on there, and you gotta be able to find the binomial on there.
It's before G.
And all you need to put in for this one, you put in the mean, which they're gonna tell you. That's another thing. If they give you the mean, then that probably tells you that you're using Poisson's. Because on everything else, we had to find the mean ourselves. So if they tell you the mean, you're probably using Poisson's. And then you put in the x. That's how many you're looking at that occur in that certain interval. Again, if we do Poisson's PDF, it's just giving you 1. If you do CDF, then that's giving you everything below from whatever number you put in for x. So if we say, what's the probability that an acre of land in Preble County has 4 or fewer cows, then we can just punch it in that way instead of finding each one separately. Mean number of accidents per month at a certain intersection is 3. This is the actual, these are actual numbers from Trumbull County that I got for 35 in Gettysburg out there.
So where's E?
E is,
Okay, how to do
if you use the formula, E is right above, it's like right next to the 4, to the left of the 4. It's got,
E with the X.
it's got the E with the X.
the, oh, okay.
So if you want to use the formula, that's where it's at. So here, the mean number is 3, so mean is 3. What's the probability that in any given month, there's going to be 8 accidents out there at that intersection? So our X is 8. If we use the formula, somebody help me out that's got the formula written down there. Probability at 8, what is it? It's the mean,
3
X.
X, so 8.
3 to the 8.
To the 8th power.
E minus
3.
3.
With the 3 power.
Or, yeah.
Over 8 factorial.
So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, if you punch this into your calculator,
Is this CDF?
you can punch in all the top and then just hit divided by and punch in 8 factorial on the bottom and it would do it.
Is this PDF?
I don't know. Are we doing PDF or CDF here?
Oh, PDF.
Because we're just looking at 8, right? So if we're, once you get that on your calculator, if you get that answer, keep it on there and we'll see if it comes out the same. If we're going to use our calculator and use the setup in the calculator, then we go second, bars, go down to B, we go down to Tucson, so say just Tucson PDF, is that what it says?
Yeah.
Yes.
And we punch in the mean, which is 3, and we punch in our X, which is 8.
You get the same thing.
Get the same thing either way?
Yeah.
What's it come out to be?
0.008.
So if we go out to that intersection, or if we stand out there at that intersection for the next month and watch, the chances that there's 8 accidents at that intersection is less than 1%. So even though it's not a good intersection, having 8 accidents out there, not very likely. Next part says find the probability that more than 4 accidents occur. So if we do more than 4, do we really want to go 4 or 5, 6, 7, 8, 9, 10, 11, 12? Where are we going to stop at? How many accidents could there be out there? Could be an infinite number. We don't know. All right? So could be a whole bunch of them out there. So we don't want to do that. Probably what we want to do is, I thought I turned that down. What we want to do is take 1 minus the probability that there is.
Less than.
More than 4.
Now this says more than 4, so we want what?
5.
We want to go down starting at.
Because you can't go
So
up.
for 4, 3.
So we want 4, 3, 2, 1, 0. Now to do that, we can punch in instead of PDF, we can do the CDF and punch in 4, not 4,
Well, yeah, but that's what the
3,
same number would be for.
and then 4. Now you got to be careful with this because you're going to give me this answer. Is that going to be our actual answer?
No, you have to do 1 minus that.
You're going to have to subtract 1 or subtract it from 1. So what's the chances, what's the probability that there's 0, 1, 2, 3, or 4 accidents out there?
185. Which is really weird because the answer is, when you, before you subtract it, it's 0.815.
Oh, okay, so the answer, this isn't, that confused me. This came out to be 0.815.
Yeah, and then 1 minus that is 1.
All right. So now I'm looking at that. There's about an 82% chance that's gonna be how 0, 1, 2, 3, or 4, that's how many accidents. That makes sense to me because if there's an average of 3, it makes sense that 0 to 4 is probably about how many are gonna happen out there. That's when you told me .815, and I'm thinking,
Yeah,
well,
that's,
that,
I
it's
see
one
that.
minus that is
then you subtract that from 1 and you get,
Sorry.
and that's the probability that there's gonna be more than 4 accidents out there. So only about an 18, 19% chance that there's more than 4 accidents.
Okay, books. Summary.
Let's go back to this for a second.
Okay.
I don't know if I can,
Appendix.
on this, if you look at your charts, I don't know if we can do that last one on here or not, I can't remember.
It's so small. I need a ruler.
If you flip back a few pages, the last 1, 2, I think the last 3, 4, 5, 6 pages have a chart for Poisson's distribution.
Yeah.
Yep.
That will be something different.
So if we look at this one, we wanted our mu to be 3 and 8 accidents. You look along the top up here, that's where your mean is. We want to go to 3, and we want 8. So 3 and 8, if we go over there, what's it say? 0.0081, is that about what we got?
Oh my gosh, I did.
So you could use the charts to do it. And again, if we were going to do this, all right, we could go find all those and add them all up from this chart and do it that way. Probably easier the way we did it. If we look at it, let's see, 3, 0. I mean, because we could find 4, 3, 2, all those on the chart. But notice the chart only goes up to 12. But what happens at 12? Look at, for 3, the mean being 3, and we go up to 12.
It's 0, 0. It's very small.
It's very small. And guess what's going to happen for 13, 14, 15, 16?
It's gonna get
It's
smaller.
going to get even smaller, so it's probably not going to matter. So we could have just took 12, 11, 10, 9, and 8, 7, 6, all the way down to 5, and added them all up. And I bet that gets us real close to .185. Even though we're skipping out on 13, 14, 15, 16, because they're so small that they're negligible, that they really don't matter.
We do not care. We do not care.
What is that?
That's the assignment.
Oh, you're talking about like these